3 modules ago we developed a model called the capital market line, which shows the relationship between total risk and expected return for efficient portfolios. In this module we will look at a similar model called the security market line. We begin where we finished the previous module, with the equation for the capital asset pricing model. The CAPM says that the expected return on a share is equal to the risk-free rate of return plus the share's beta, which measures its level of systematic risk, times the market risk premium, which consists of the expected return on the market minus the risk-free rate of return. We're going to develop the security market line by graphing the CAPM formula. If we look at this formula, we can see that it is a linear equation. It's a straight line. And the generic formula for a straight line equation is y equals mx plus c. This equation shows us the relationship between variables x and y, where c is the y-intercept and m is the slope of the line. We'll change this formula around so that we can see the correlation between it and the CAPM formula. Because it doesn't matter in which order we carry out addition, we will swap the c with the mx, and because it doesn't matter the order in which we carry out multiplication, we'll switch the m and the x. If we compare these two equations, we can see which variables line up. For example, the dependent variable, the variable on the y-axis, is y and the expected return on the share. The constant, or the y-intercept, is c or rf. The independent variable that is shown on the x-axis is x and the beta of the share. And therefore the slope of the line is m, and this term in brackets, the market risk premium. So now that we've identified the components of the CAPM formula that will allow us to graph the line of the formula, we will plot the line on the same set of axes that we've been using, where we have return on the vertical axis and risk on the horizontal axis. So we'll take the y value, the expected return on the asset, and label the y-axis accordingly. We'll take the beta, which is the x variable, and label the horizontal axis accordingly. We'll take the constant, rf, or the y-intercept, which we know plots on the y-axis because it has a risk and therefore a beta of 0. Now, in order to determine the slope of the line, we need at least one other point. And there's one other point that we know something about, the market portfolio, because we know that its beta is 1. The expected return on the market is simply the expected return on the market. Now we'll draw the line between these 2 points. The simplest way to find the slope of a straight line is to find 2 points, which we've done, and the slope is equal to delta y over delta x, or as some people say, rise over run. So as we move from m down to rf, the change in the y variable is the expected return on the market minus the risk-free rate. And as we move from m to rf, the change along the x-axis is simply 1. We know that anything divided by 1 is equal to itself, so therefore we've determined that the slope of the line is the expected return on the market minus the risk-free rate. The market risk premium, which we previously identified based on the analysis of the formula as being the slope of the line. This line is the security market line, or the SML.